Finding the marginal probability mass function, PMF. This study provides a comprehensive guide for learners on how to find the marginal PMF, complete with a worked-out example and scholarly references for further reading. Understanding probability mass function, PMF. Before diving into finding the marginal PMF, it is essential to understand what a PMF is. The PMF of a discrete random variable gives the probability that the variable takes on a specific value. Mathematically, if x is a discrete random variable, the PMF, p x equals x, is defined as p x equals x equals p x backslash in A, where A is a subset of the sample space. What is the marginal PMF? The marginal PMF refers to the probability distribution of a subset of random variables within a larger set, ignoring the others. In simpler terms, it allows us to focus on one variable while accounting for the presence of others. For instance, if we have two discrete random variables, x and y, the marginal PMF of x can be derived from the joint PMF, p x y, as follows. P x equals backslash some underscore y p x equals x, y equals y. This equation sums over all possible values of y, effectively marginalizing out y. Steps to find the marginal PMF. Finding the marginal PMF involves a few systematic steps. Identify the joint PMF. Start with the joint PMF, p x y, that describes the relationship between the variables. Sum over the unwanted variable. To find the marginal PMF of x, sum the joint PMF over all values of y, or vice versa. Normalize if necessary. Ensure that the resulting PMF sums to 1, confirming it is a valid probability distribution. Example scenario. Consider a simple example where we have two discrete random variables, 10, representing the outcome of a dice roll, values 1 to 6, and y, representing whether a coin flip results in heads, h, or tails, t. The joint PMF, p x y, is given as follows. Step 1. Identify the joint PMF. From the table above, we can see the joint PMF values for different combinations of x and y. Step 2. Sum over the unwanted variable. To find the marginal PMF of x. P x equals 1 equals p x equals 1, y equals h, plus p x equals 1, y equals t, equals 0.05 plus 0.05 is equal to 0.10. Continuing this for all x. Backslash begin, align asterisk, p x equals 2, and equals 0.10 plus 0.10 is equal to 0.20 backslash p x equals 3, and equals 0.15 plus 0.15 is equal to 0.30 backslash p x equals 4, and equals 0.20 plus 0.20 is equal to 0.40 backslash p x equals 5. And equals 0.25 plus 0.25 is equal to 0.50 backslash p x equals 6, and equals 0.05 plus 0.05 is equal to 0.10 backslash end, align asterisk. Step 3. Normalize if necessary. To ensure the values are valid PMFs, we can check. Backslash sum underscore, x equals 1, caret, 6, p, x equals x, equals 0.10 plus 0.20 plus 0.30 plus 0.40 plus 0.50 plus 0.10 is equal to 1.60. Since this does not sum to 1, we must normalize the values. The normalization factor is, January 1st, 60. Final marginal PMF of x, after normalization, the marginal PMF of x becomes p x equals backslash frac p x equals x 1.60. This process illustrates how to find the marginal PMF effectively. In conclusion, finding the marginal probability mass function PMF, is a fundamental skill in probability theory, especially for learners in electrical and computer engineering. By following the outlined steps and using the provided example, you can confidently analyze joint distributions and derive marginal PMFs. For further reading and scholarly references, consider exploring the following. Probability and random processes. Elements of information theory.